Hey, this is Mr. Dan. I'm with Touch Technologies, and today we're going to be talking about another Sheerpower feature. In particular, we're talking about database access, as you can see right here. Just an introduction. So Sheerpower includes its own integrated high-speed database engine called ARS, which is an advanced record system. In addition, Sheerpower can also access other database engines, MongoDB and other types of engines. ARS was originally developed so we could capture video frames at super high speeds. And in particular, ARS, for instance, reading records sequentially. We can read about 500,000 records a second. We can do key lookups in less than 100,000th of a second, so it's really, really fast. Database access is integrated directly into Sheerpower as opposed to being an add-on like other languages tend to have. And here's an example of our open statement. We say open table and whatever word we want here. I'm using the word words. And we're going to open up a database table called dictionary. So the reference name is words and the table's called dictionary. We could have called this dictionary. I just didn't want to type in the whole word dictionary every single time. It would have been annoying to do. So a table, just a little review for you, it consists of records and fields. That's what all tables look like. Each record contains a set of fields. In Sheerpower, to access a given record, we first have to make it current. That's the terminology. It's called current. For example, let's make a record current associated with the word flower. And here we go, set table words. Again, the reference word here. Field word, which is the name of the metadata within the table, and our key data is flower. And then we're going to print the word definition. So this is how we would do all that. Table data is accessed through dynamic variables. In this example, this entire phrase here, the words open parenthesis, definition, close parenthesis, this is the name of the variable. Yeah, it's got little parentheses in it, but it is the name of the variable. It stands for the table name and the field within the table. These variables also perform all the needed I/O and locking operations, explicit, implicit locking. It handles everything. So a programmer type doesn't have to worry about those details when doing database access. We can iterate over all the records in a table using the extract and end extract statements, such as extract table words again, print words, the word, end extract. This particular dictionary has around 90,000 words. So this would be kind of a long list to print out. Because tables tend to contain a lot of data, we usually use include statements and exclude statements and other methods to get subsets of the records. Here's an example. I'm saying include all the words where the first three characters, positions 1 through 3, please remember that Sheerpower is one origin, so it's position 1 through the third position, is going to be equal to ABY. I like the word abyss as an example. And then we're going to print from the words table, the word, whatever that word is, and extract. This is our iteration that we use. Unlike other programming languages, database operations are integrated directly into Sheerpower as language statements. This means that Sheerpower is immune to SQL injection attacks. We can do another talk on SQL injection attacks, but we are immune to them completely. And we're also immune to other methods to trick programming language into executing database operations within strings. Why is that? Because we don't use string data in order to access an external database engine to do our work. And that's what makes us immune. Within the extract and extract block, we can also request sorting of data. The data we sort can be from fields in the table, or we can create some kind of expression, and we can sort by the results of those expressions. In this example, we're going to get the length of each word's definition. We're going to sort descending by that length. So here we go, extract table words, include words, 1 through 3 equal ABY. Same thing. Sort descending by what? Well, we take the word definition, we get the length of that, and we're sorting descending by that. So the longest definitions will be first, and the shorter definitions will be next. After sorting the data, we need to access each record in its sorted order. And this is done with the for each statement. This again is the iteration for each of the words, print words in the word, and end extract. The extract and extract made a collection of records for us. The for each iterates through the collection, one record at a time. Sheerpower uses a globally shared memory cache to keep table records, partial table records within it. And it uses this, because it uses this cache, it doesn't have to bring into memory every table record at once. A lot of programming languages, when you send like an SQL request to receive a million records, all million of those records have to come into memory for us to access them easily, or you have to use some paging system or something else. You don't need to do all that with Sheerpower. It handles everything for you. This means even on a memory limited system, Sheerpower can handle multiple millions of records at once. So it's pretty nifty for you. One of the coolest things that Sheerpower does is it makes table updates really trivial. When you open a table, use the access out in option. By default, when Sheerpower opens up tables, the default's read only, just as a protection. But you say access out in, that says you're going to read and write. This tells Sheerpower the table updates are allowed. So what you do is you open the table, you make the record current, and then you store the data into the table field expression. Here's an example. We're going to open the table. You notice it's access out in. We're going to look up the flower, the word flower again, and then we're going to update the definition by saying words definition equal a lovely plant. You'll notice this looks just like a variable is, because it is a variable. However, it also does the implied record locks that are necessary, so we have exclusive access to the flower record, and it updates the information. It flags the, if necessary, it refetches the current record, it locks it. It stores the updated definition into the record buffer. It marks the record buffer as needing a disk update, and it then does the disk update when necessary. So Sheerpower handles all this for the programmer. You don't have to be worried about some kind of special calls or commits or anything else to make this happen. So let's say, for instance, we want to prefix all the word definitions with the text of DEF and a colon, extract table words, words definition equal the string DEF with a colon, plus word definition. This would then go through all 90,000 words and put DEF colon on the front of those words. So that makes that part pretty cool. Now let's play around a little bit, because that was kind of our quick introduction. Let's play and see how this works. Open table words, name dictionary. Dictionary is the name of the table itself, the actual inside the database. But words is our reference name. I'm mostly doing that because I don't want to spell out the word dictionary each and every time. Let's do something pretty simple. Let's set the table words word, and we're going to say the key is flower. Print the words definition. So pretty straightforward code. Let's run it. And it says the blossom of a plant. So that's pretty simple, really easy. And let's say we want to do something more fun. We'll leave this here, but we'll also do a extract table. I did a little shortcut here in the IDE to a little template that did this extract table for us. Words, and then let's include the words in some word. And let's say positions 1 through 3 equals ABY, just like we did in the PowerPoint. I spelled the word include wrong. Let's fix that. And then let's print the word. Let's run that. And you can see here are the words. All the nice words that start with ABY. Let's print out some of their definition too. What the heck? So let's print the words definition, and then we'll skip a line or something. Maybe we'll just delay so we can see it. That'd be nice. Here we go. ABY has no definition. ABYE, archaic, to pay the penalty of. Some of these words don't have any definitions, so they're kind of not as much fun. So why don't we close this, and we will say exclude from words the definition equal nothing. So we don't want to end up with, we don't want to look at the ones that don't have definitions. Here we go, and here we go here. Nice and simple. And there's our information. Let's go back to flower here. We're going to change that a little bit. So now we're saying access out, and that says we can make modifications to the data now. So let's just go run this again to take a look at the definition of flower. And you'll see it says the blossom of a plant, right? We're going to change that to say something different. We're going to say words definition equals lovely part of a flower. So we're storing data into, again, this is treated in Sheerpower. This looks like a variable, just like any other variable, except it's doing implied IOs. In this case, it's actually refetching the record if necessary. It's locking it if needed, and it's updating the database record information with the new definition. And to prove that, we're going to put a delay right here so we can look at the new definition. So we're going to run it, blossom of a plant, do our little delay, and it's done. Let's run it. And look, a lovely part of a flower. So it made the actual database change. All the concurrency was handled with this. Sheerpower can do 50 to 100,000 record updates per second. It's very, very fast. It uses a global memory cache to do its work. The more programs you have that are running Sheerpower, the faster this will run. So Sheerpower can handle really, really large data sets and really, really fast transactions. That's our introduction to Sheerpower database tables.